Yes, hello. Yes, Dano. Hope my voice is visible, is audible.
Well, I can hear you well.
I've been good. Yes, I've been just setting up my workstation here. Yes. Good evening. Good evening, members from Uganda, because it is evening. It is 6 p.m. I'm so delighted today to host Dano. He's a SolidWorks champion. He's an expert in SolidWorks and is an elite application engineer. And I'm so glad to have members all over different countries, all over different continents, coming together to explore more in the area of design, in the field of engineering. I welcome the different SWUG members on the session. I welcome the different application engineers, elite application engineers, SolidWorks champions, and all SolidWorks users. So today we are hosting the Know as Uganda SWUG with the topic routing, that is piping and tubing, getting started. Whatever you need to know in piping, I decided to look through my logbook to get an expert I can trust in this field because I've been using the software for over 10 years. And I'm so happy that today is going to present, and I believe we are going to gain the best of it. Personally, I'm on Dream. I'm a Uganda SWUG leader and I'm a SolidWorks champion. I welcome you all. Now you can take over. Thank you.
Thank you, Antua, for the introduction. So I'm just gonna roll up here and share my screen. I hope that everyone can hear me well. Okay, this should. Okay, and sharing screen. All screen. Okay, can everyone see my screen fine?
Yes, personally, I'm viewing it perfectly.
Okay, excellent. First of all, Antua, thank you for hosting me for today's presentation. Also notice this is my first SolidWorks user group presentation, so welcome aboard. My name is Dino Pechenyev. I'm coming from Croatia, from small town Bjelovar, and I'm working as application engineer. This year marks its 6 years. So I started in 2020. I become elite expert in 2020, elite application engineer in 2022, also SolidWorks champion, and there's also a new exam, job site professional as well. So some 2D CAD. In free time, well, I like to learn a bit more about SolidWorks as everyone, but as a hobby, it's playing an instrument, specifically guitar. So let's get this show rolling. So what is routing? Well, routing is basically an add-in that involves creation of routes, and with specific routes, it's piping, tubing, which are today's topics, also electrical cable and wire, electrical conduits, and there are also, besides this, there are also user-defined routes such as HVAC, ducting, cable trays, or if you want, you can even make something else. So it's quite roundabout and pretty robust. So we're gonna go with some starting techniques so you can easily get going with routing. So the results is we get actually solid parts. It's not something that is cosmetic or anything. It's actual parts. So we have several categories. So besides some cables, pipes, tubes, and everything, it can also be a specific material and everything. So we're going to go through it. So regarding the feature manager tree, as you can see on the left, specifically the icon at the top left near the name of the assembly, there's a little icon next to the assembly icon. It means this is a route. So when routing is basically made in assembly, so it's not tied to the parts. And what we're doing, we're basically inserting some components, start and end components like flanges, or we can start from already inserted components, which I'm going to go through all. And we basically make a 3D sketch. And after we make a 3D sketch, while we are making 3D sketch, we get all of those components and route parts created immediately, and they are all separated in according folder. One thing to note, you can see that in the feature manager tree, we have components which are actually external files saved to the disk, and we have route files which are internal to the route assembly. So this simplifies renaming and deleting options. Specifically, it's some good practice regarding using virtual components to start with the virtual components, and then when you are ready to create drawings, then save the main route assembly as external file. So it simplifies delete because it simplifies the rebuild operation. We also we can easily change the name. We can always save or make it virtual again, and it simplifies the file naming for the end process. Deepak, you have raised a hand. Do you have a question? It's maybe a specific. Okay. So also, besides the file naming, we have the subassembly and route part naming. So while we're continuing, the main thing that we need to take care of is our routing library manager. Just like in regular SolidWorks system options, we have external application routing library manager, which can take care of all of these things, but most importantly is the routing file location and settings, which is where we define basically where is our library, what is our default template, and such. So this is the thing. And when we go to the file locations, we can see the following. We can see where our routing library is. And after that, we can see that that location is extended to piping and tubing and electrical cable to specific files which take care of the as standard tubes, covering library, tag scheme, and for electrical also about cables, components, and such. And here, as you can see, the second row in the table in general routing is actually the routing template. So besides like in SolidWorks, we have sectioning option for setting default templates. For default routing template, we define it in routing library manager. So our typical piping route, what does it consist of? It consists of components and route parts. So I made different colors, so just to easily make it visible. So components are basically flanges, crosses, these reducers, valves, other equipment, and for the parts, it's actually the pipes that are created alongside the route. And how is everything connected? This is most important part regarding with connection points. This is a lot of text, but we can summarize it simply. So the connection point is basically where the route begins or ends. We can also have open pipe with nothing at the end, of course, but if we put a flange, for example, the connection to the pipe is going to be from the connection point. And then we have routing points, which is actually for positioning the fittings. Let's say we want to position a cross or T. When we position it on our route, it will the center for connecting that component to the fitting is actually a route point. And let's start with the actual routing. So first thing first, we need to create our default template. Now, this is important. The route template, when you start the add-in for the first time and start the routing library manager, you will have in the default location, which is on C, program data, SolidWorks version, design library routing, there will be route assembly estimate, but actually, pardon, this is mistake. I will make it correct for the PDF you will have as a handout. And then we're gonna set for this template system options, and we can choose it as a default template in the routing library manager. Main thing is this template is not the same as a classic assembly template. Why am I saying this? If you take a classic assembly template for this and save it like as a route assembly template, use it, you won't be able to start a route. So this is important. So all the settings that you are setting up for your regular assembly template, you need to set it up for the routing assembly template again. And let's get to the demo. So first thing first, I'm going to open up the I'm going to open up my SolidWorks location, so version, templates, and here is routing assembly. When setting up the assembly, I'm just going to change few settings for this presentation. So I'm going to check for the dimensions. So I'm going to set it up for 28 points, just to make it a bit more visible. And I'm going to do something unorthodox for me. So I'm going to change the units to actually feet and inches. So bear with me regarding this. At the end, we're gonna switch to the millimeters. So I'm doing this because I want to focus up on the techniques rather than the dimensions. Okay, so we have everything set up, and now it's just a regular assembly template saving. So I'm just going to name it feet, inch, route assembly template. And now, as I mentioned, we have here in system options default templates default location, but this is for assembly. So if we want to change our default template, we need to go to the routing file locations. So the routing library manager, routing template. So here I can set up my default template. I'm going to set it here. Also, the options routing library manager units, you can set it also here. I'm just going to leave it here as inch. So I'm going to set OK, and we're ready to start. So before I begin with the presentation, just to make some things a little bit more visible, I'm just going to change few system options specifically for routing. So I'm going to leave out save route parts externally, and I'm going to turn off save route assembly externally so I can easily manipulate my routing assembly for the file naming. Also, we're going to choose automatically route on drop of the clips. So if we don't even start a route, if we're going to do drag and drop, we put a clip here, we're just going to use here. And we're going to use center line dimensions for our whole route. So we know specifically where we're going to locate everything, and we're going to use a triad to position and orient component on job. And if we want to change, for example, a component, we can also turn on use configure component to select configuration for the component we've already set. For regarding the spools, I'm going to touch this a little bit later. And for colors, I'm going to change use specified colors when editing parts in assembly. For display, I'm going to say pack assembly for assembly transparency in context edits and assemblies, assemblies and large assembly settings. I'm going to turn off to hide all the planes and axes I want them to be visible. So this is just presentation wise. We got our template set, few options, and we're ready to get back to this. So for the second step, while we're, let me just take a look at the chat. So special petrochemical plant. So regarding the, okay, so for the questions regarding the specific tools, SolidWorks can ease up using the routing regarding this, but this depends on which scale you need to do it. So you can ease up if you're doing just a quick notice. If you're doing process and ID thing, then it's understandable to use something else because SolidWorks can't make the isometric drawings. I know this is quite a big topic regarding the PI and ID, but yeah, in SolidWorks that's part not possible. And regarding everything else in routing, you can simplify a lot of stuff. If you're making, for example, equipment, you can change it, let's say hydraulics and pneumatics, or maybe some plant specific things. So that's why. I hope this answers your questions, Mr. Ali. So back to the presentation. So we're going to start the route with basic drag and drop. So from the library, from the task pane, we're going to set, when we do perform a drag and drop, we're going to set the route properties for pipe, bends, and elbows, etc. Then we're going to add another flange, and what we're going to do, use the auto route, since this is going to be a simple one, and create the whole route with this process. So we're going with the demo number 2 and back to the SolidWorks. So I'm going to just open up here simple assembly. And for this, I'm going to prompt the user to select the document template so you can see when I'm selecting. So as said, what I'm going to do. So if you can see, this routing folder showed up. This is important. This is actually part of the design library, but just to notice, this routing folder doesn't need to exist in here. It's just, this is a separate section, so you can put it anywhere you want. Just make sure that in the routing library manager, you put the right location to it. So we're going with the piping. We're not going to do anything special here. I'm going to use display state, not structural. And for the flange, I'm just going to drag and drop one. This uses mate references, so I'm going to use slip-on flange. So if any configuration is not listed here, I can use always checkbox list all configurations just for a notice. So I've set my first flange. I'm getting my information, but I'm using the default template I've set. So here's the pipe. If I need, for example, different pipe with different material, I can select it. Bends and elbows, I can say like use form bends, or I'm going to say I'm going to use elbows here. And what is a good thing here, it automatically sets the appropriate configurations. So for routing, it's a key thing that the configuration needs to exist in the starting component, and it needs to exist for the pipe to be automatically recognized, and for the elbows as well. So we have also coverings here, which we're going to touch a little bit later. For parameters, this is set already in the components. Here, routing specification, we're going to touch that in the next part of the demo. So regarding the template, I'm going to set feet, inches template. I've set, and I'm ready to go. I'm just going to drop here another flange with the same size, use auto route, and just to notice here in the command manager, you have 4 different sections. Some commands are the same, but for example, for drawings, you need to be use the specified, like tube drawings if you're doing the tubing drawing, for piping drawing, electrical and such. But auto route is a general thing. So when I'm doing this, I have routing mode auto route on. For piping, the key thing is tubing can create flexible tubes. Piping does only orthogonal route. For if you're using auto route, it's only this one. So for the start and end location, it's easy. We're just gonna click the start point and end point. I could have done it other way, and please notice that the mouse icon changed. So with the right click, I can select different proposed solutions, and when I'm done, I can just click left click and it's done. And here, this is alternate path. So this is here, the solution is light up. So if I see the solution I like, I can use it from here. And I can just say, okay, I'm not going to go a little bit more in detail for this specific route. I'm going to go exit, and this part of the route is complete. So this is a virtual route for now, which I'm going to use, and I'm just going to do a quick rename. So I'm going to just name it 6-inch route, and we're done with the first part and the first route creation. Now, for the second part, for the third, we're done, and we're moving on to the third part. So I mentioned the route specification template. This can ease up the whole process we're doing. So if we know that we are frequently using some sizes, what we can do, we can create the certain template for this and always call it up for and always reuse it. We're going to create a new route with a 3D sketch. Also, for the third route, we're going to use this specification we're going to do, and we're going to use a clip. So moving on to the third part of the demo. So we're going to use the specification template. So before I start with the route, I need to create this template. I can access the tools, routing tools, routing library manager. This is one part, or go through the options. So here, what we're going to do, we're going to load up this section. Just wait for the routing library manager to fire up, because this is a standalone application. So we're going to say route properties. We're going to add new template, and let's say we're gonna use, we can use any part of any naming we want, just for easier. We're gonna use schedule sizes. We also got different sizes to use. For pipe, we need to select the pipe. Here specifically, doesn't matter what we're going to, which pipe configuration I'm going to use. And why am I saying this? Because when we use specific flange, it will automatically use the specific schedule. And here is important thing. So we're gonna use elbows here. So always use elbows. So for the elbows, I'm going to search the database for a class. I also have a, or actually for a schedule, no, schedule, and I'm going to say schedule. File name 90° actually inch 3, or there are different names, so be careful about that. So it will list up everything. So I'm going to use this one. So I'm just used to selecting the same size, but it's all right to create any. So here, the important thing is that the custom album, we're going to add new one. So why is this important? Because here I'm going to use the 45°. So 45°, just or inch table. So we're going to use this one, and we're going to select the appropriate side, select the components, and what is important here, without choosing specific 45° elbow, we need to specify it later. But if we use the route specification templates, we can automatically make use of it. So I'm just going to hit up save, and if I need it, just a quick notice, you can save this as a template. You have save settings. So if you create this, you can transfer this to another PC, similar like SolidWorks settings. So with this part, we're done. So I'm just going to leave this open so it doesn't take much to load again. Here, I'm going to create another display state, lower tanks only, and I'm going to activate it. And for here, I'm just going to do this and hide the components. So we're going to start a new route. Going to do the upper part of the route. Let's say we're going with this one, and it will automatically set the sizes. But here we are using route specification. If we modified any option regarding this, it will prompt us that everything will be overwritten because it will use the route specification template. So with this, I'm set. I can start the route. I will select my template. And here for the sketching, before I start sketching, I'm adding just another end flange. And one important thing here, I'm just going to reorient here at the top. Just going to switch it. And when I'm doing, since we're doing 3D sketching, if you're instead of like putting the point and running through the tab, if you reorient, for example, to the top view, like here, we can just leave it like here. So I'm just going to sketch a simple route. So when we are now in the ZX direction, you can notice in the lower left corner, I'm just going to sketch the route before I finish. And one important thing here, when ending the route, don't do this part, because ending here, and if I connect it here, what is going to do, this is going to create actually two pipes here. So instead of doing this, use the option merge as a relation, and then you get one pipe here. So for here, I can just use I'm just going to use some specific dimensions regarding this. So I'm just going to dimension. And if you notice that in routing, when I'm creating the dimension, this is going to be 1 feet. It's actually using the whole length of this section. That's why we set the option to use center line. So it goes from the start and right at the crossing of the two intersection of the two lines. So I don't have to deal with like pressing where to here. No, it's just going to do the whole section of this. And I'm just going to put the dimensions. So 1 feet, for example, 4 inches. So this, I'm going to use the 45-degree angle. For this one, it's going to be 4 feet. And for this specifically, I can just drag and drop it, regular sketch, and I'm just going to do a 1 feet. And my route is complete here. So this is for the second route. And for the third route, I'm just going to switch display state to the default one. And I'm going to start a completely new route. And I'm going to do so we're going to use this size, 150 NPS 3. So I'm using this size. It will automatically recognize, if you can see, even though I named it schedule 40, you can see the pipe is 3 inches, but it uses this schedule as a size. Again, using the template. And now what I'm going to do, I'm going to drop a clip. Why use clip? Because I want to focus up. I want my pipe to go through the floor from the upper section to the down section here. So how can I do this? I can do this simply. I'm going to use a razor clamp. I can press it here and I can rotate it if I click and hold shift on the keyboard and use the arrows to actually position it. And for here, this part, I can use the auto route. And the important thing is the clips don't need to specifically like be geometry. You can actually use also virtual clips for the ease of the routing. So I'm just going to use the this part. I'm just going to use the axis, and this part of the route is done. And I click done. This part is completed. So if I run down, this is all right, and it's set. So now for the last one, I'm just going to finish the route. I'm just going to drop another flange down here, just simple drag and drop, select the same size, and I can do the sketching, or I can just do simple routes like this, or it can go like this. I think this will be suffice. What I also want to show here, now that we continued the piping, so if I can move this, I'm just going to select this line and select the center line that was created because of this clamp of this clip. Use set collinear and we're set. Also, if I want, for example, from this upper part, dimension, I'm just going to use dimension, shift click and select the face, and I can say like, I want this to be 1 feet away from the upper face. So we can reorient that as any way as we like. So, and the next part we can like, I can leave it like here, which is okay. So here we will have interesting scenario, which we didn't encounter. So if we don't set our elbows to use 45-degree elbows, we need to set it manually. So this is like setting up manual. But for here, this is at a different angle, and I will say for here use the create form bend. So for this specific scenario, when I exit this part, if you can see in the feature manager tree, instead of getting 3 pipes, I get 1 pipe. So let's say design changes and I want to set an elbow here. I will just go to the right click, edit route, right click on the fillet, and instead don't look this part, it's actually here, elbow angles. And here I can say 45-degree elbow radius, I can use it, but this is not 45 degrees, so I'm just going to use the I'm just going to set cancel. Or if I want to remove the form band, I could do it with this option. So once again, right click, elbow angles, and this prompt window appears. So this is for our third part where we use the clamp as a clip to complete the route. And let's move on to the next part of this session. So what we're gonna do, we're gonna use some additional fittings and we're going to use coverings. So fittings are usually can be placed on where we split the route. We can do this route splitting manually, or we can just drop the fitting. I'm going to use all of these scenarios to showcase this. And you saw that if you are paying attention that when I wanted to remove a pipe, I deleted part of the sketch. Now, that can be tricky if we, for example, want to do after the elbow, let's say we want a T, and if we want it connected and we have a small part of the pipe, instead of deleting the portion of the sketch, which could create some complications, there is a simple option just to remove the pipe automatically. Also, the coverings section, all the information for coverings are set in the routing library in the coverings XML format, but we also can create our own coverings and they can utilize SolidWorks material database. So usually coverings are, for example, let's say we want to add insulation on the specific sketch segments. So for here, we're going to move on to the demo number 4. So here we're going to continue. I'm just going to go to the lower tank only. And at this part, I want to connect this part with this section. So for this, I'm just going to edit this route. Since the design was not completed, I didn't save this externally, so it's still a virtual component. So I'm just going to do edit route, go into routing library, piping, and let's say I want T specifically. And let's say I don't want so since here it's different flange, we want a reducing T outlet. So I'm just going to use the drag and drop. It will place on the route, and I'm just going to click tab on the keyboard to change the angle. And for the size, what I'm going to create for the size, I'm going to use the 6x6 and 4 inches. So if I need to control this, I can use either with the library, I can control this, or this is not completely fixed. So let's say I want this part to go along y-axis, and this is all set. And here, let's say we're going to add 2 more flanges. So just drag and drop. We're going to use this. We're going to place one here. So what we're going to do, I'm just going to use the auto route because this is a simple part. And I'm going to use this solution. And let's say I want to continue this part to here. So for this example, I'm going to use a straight T and just put it upwards. And this is the same size, so it continues. And what I'm going to do here before I finish my route, I'm just going to take the line from here, put it here, and just going to do a quick merge section and move it away. So let's say I want this in a specific place. I can say like to the top plane, and I'm going to say parallel. So this part is set. So you can always use the relations to set this up. Here for the end, I'm just going to say make this equal, create the part, and don't worry about this. This will automatically update. So I'm just going to dimension this part with 1 feet 9 inches. And the important thing, so I mentioned the connection points and route points. And you can see that the connection for this T is in the center of it, and this is where the routing point is used. And at the ends, where the pipe starts and ends, it uses connection points. And for here, let's say I want to use 1 feet dimension. This is all right. And let's say here I want to use two. Actually, we're going to go with 1 feet, and we're done. So for the next route, what we're going to do, we're going to go from here to here as a separate route, but we want to use some of the relations that when we change this part of the route, the height also changes here. So I'm going to do a simple thing, just add a plane related here. So we're going to do on the top plane to here, and I'm going to say here that it's parallel. So I can utilize this plane for later use. I mentioned coverings, so we're going to do it now. I want to do the covering, and what we're going to do, I can create the whole section auto fitting, for example, here. We can use the covering library we defined in the routing library manager, or we can use create a custom covering, define this thickness, for example, select material. The material is actually which is used is from the SolidWorks material database, so you can have also additional control over it. And we're going to say apply, and it's set. And here apply, so it's set it. Also, one thing to notice, you can also add additional materials. So it doesn't need to be for the coverings that it's only one material. So if you have a need for the multiple materials, you can set them here. So this means if I need, for example, glass, and then I need to add, let's say, tape, I can add it. I can also change the position which part of the covering is located. And also, if I need to edit it, I can just run the command again, select the same part of the routing, and it will show up which routing coverings I used. And when I exit the sketch, so here, if we're going to take a look here for the components, not this part. So here it will create in routing parts. We have a specific part which is covering, which is good because if we need it in a bill of materials, it will be shown. So we get all the information we need. And let's start with another route. I mentioned split route. So we've done manual automatic splitting with the T's, but what if we want to, for example, want to have more control over it? So it would be slip on well flange. I'm just going to go here. So I'm going to select and 150 or 400, simply NPS 4 for this part. And we're going to use a specification template because we have all the settings we need and we're using the same template we created at the start. So for this, I'm just going to put the flange here. Actually, I need to change this. So how I can change this, I can just go back, exit the sketch, and I can say like either configure component, or I can just select it here. So I can change. So it's basically we use the configurations, nothing additional regarding that part here. the CD NPS 4. Okay, and we're rolling. Right click on the route, edit route, and we're doing it again. So for here, we're just going to take this simple solution, what we're going to do. And for splitting the route, if we need to specifically control it, we can do two things. So for those things, what we can do either right click and we can say split route and we can place the points, or we can do, for example, use a line and create a construction line. Why am I doing this with a construction line? Because this will ease up the whole process of positioning my T in the given assembly. So I'm just going to go here and use the front plane and say this is going to be parallel. And with this, I can easily control it if I need to put on the sketch, if I need to put the specific angles. And now when I go drag and drop it, what you can notice, it takes that point and center line actually as the splitting part of the route. And here we're done with this part, but I mentioned also the use of the function called remove pipe. So instead of removing this, but then what will happen? This will happen. I don't have an elbow, but I need to keep this elbow. So what we are going to do, I'm just going to finish up this. I'm also using auto route for this presentation because I'm focusing up more on the techniques used here. So this part is done, and what we're going to actually, I could have used the different solution for the I removed the flange a little bit, Control Z back too much. So auto route, we're going to complete this, and we can take this. It's all right. So I can just simply put the desired angle I need. So I have a 45-degree angle here. And this part, instead of deleting and everything, I'm just going to say where I want to remove the pipe. So this portion, right click on the part of the routing and remove pipe. Right click, so I'm just going to do Control Z. So right click, we have remove pipe, and it automatically switches the position. And with this, my routing is done. And the last thing I'm going to do, I'm just going to use the plane I created before the previous route. I can use that specific plane, and I'm going to say on plane, so I get the same height propagated here. One thing, important thing to notice, the parts are not the main source of the information, which means if I go to edit routes and I, for example, just edit the assembly and I just do this, I can take, let's say, this elbow, this, I can just delete it. The sketch is actually the main carrier and holder of the information, because when I go back to edit route, it will automatically rebuild my whole route based on the sketch. And also, when editing route, there is option right click, which is specified for this part of the route. So because it goes from the T to the flange, right click, and we have route segment properties where we can edit if we're, let's say, we need different pipe or anything else to use. So that's where we use this part. And we're done with this bit, and let's go back to the presentation. So for the next part, we're switching over to the tubing. And we're going to use, for example, mixed tubing routes. Again, This is a difference, but what you can see here, there's a big main difference between the pipes and the tubings. The main difference is how the components are created, and with the piping, why it can only use orthogonal routes, it's because the pipe is made with the extrude feature. And for the tubing, we can do, okay, we can do like rigid orthogonal routing, but we can also do flexible routing. But the pipe itself, sorry, the tube itself is actually made from the sweep function, and hence why you get, we have like only 4 tubes and we don't have elbows and everything else here. But everything else pretty much stays the same. So the analogy throughout the routing is the same for any type of routing we're using. So for this, we're going to create flexible route, orthogonal route, and mixed tubing route. We're going to use route through clips, and we can use also start route from already existing component in the assembly. So on to the demo number 5. So what I'm going to do here, I can simply save this. I'm going to keep this externally, but if I want, I can save specific bits externally. So for the next bit, we're switching to the tubing, and we're going to use just a portion of the assembly, so we can focus up a little bit more of it. So we have piping library, just like that. We have tubing library, so we can use the tube fittings and we can use it to start the route. So I'm going to just do 3 simple routes. So let's say we want flexible routing first. I can check which one I need, and here is the important bit of information. So if we need to create a flexible route, we need to turn this part on, use flexible hoses. If we need multi-body parts, we can do it, but we're just going to keep it as one. And we're going to start the route. Use the same information, and I got my connectors. And here, when I use the auto route, what I get here is actually a spline. I can segment it. I can use any spline information and functions I've used before. For regular sketching, important thing to notice is that the ends need to be tangent. And here, this part, my flexible tubing part of the route is done. I got 1 tube, and also regarding the tree, I have the information. I have the information about the length of the tube. We are going to touch drawings a little bit later. So I can create. I mentioned also the regular one. We're not going to be using a flexible. So the same thing is again, I'm just doing the rinse and repeat action. And regarding the route, here you can see I didn't click the use flexible hoses. I just then automatically propagates to use orthogonal route. And with this, I can create and finish my route. For this example, this is going to be just fine. And now we're going to connect this portion. We're going to use clips to route through the clips, and we're going to connect it through here. If you notice the in assembly, so this is not the part of the routing assembly, this is part of the regular assembly, but we have routing components. If the routing components are set in the assembly, we can utilize the fact that they have the C points. So what we're going to do, we're going to start routing. So I'm just going to put it here. We're going to use the flexible hoses for this route, the template we have made. And okay, so this is started. And for the clips, I can use the tubing clip. So again, it uses the mate references. I can use the shift and right arrows to rotate the route. And what it does when you use the clips, this also propagates, for example, to electrical routing. It will automatically route to the other side. So here I can just set Okay, I need another clip. It will route it. And this is all right. I can manipulate the sketch. But let's say I want to use like this. And if I want, I can click on the clip, on this part section of the clip, right click, flip direction. And also, if I want, I can use it like I can disconnect it, but I'm just going to keep it here. And if I want to change direction, right click, flip direction, and it's set. And for this part, I wanted to connect it here. So we have this component. So it has C points. And what is different here, I'm just going to click on the right click on the C point and said add to route. And it will automatically create the stub. And I can just finish up this portion of the route with this part. And it's going to end it. And now we're going to go to the other side of the route. So we can just do the rinse and repeat. We can finish it. So tube fittings. So I can use a straight fitting. So I can set it here, for example. So again, I'm placing everything with mate references, but you can also edit the locations per your requirements later. So I can just use, let's say I'm going to use orthogonal route here. So I'm not going to do a flexible one. So we have this, and I can create a T and connect it. What I want to show here, when we're doing this bit, when we have the component that is not part of this routing assembly, we have it, this part of the route might seem disconnected because here 4 components and everything is this, but not this part of the fitting. So how this can be used later for utilizing the drawings, because I want to, let's say, I want this hose with this fitting on one part of the drawing, one sheet, and this part, let's say, separated on the different. We're going to touch that soon. So let's go back to the presentation. We're going to deal with the most important thing in routing at all. So this is important, changing the route diameter. So how we can change the route diameter easily without having to think about so many parts, so many aspects of the design. So we have option to change route diameter, which will take care of multiple things for us. So we're going to move on to the presentation because this part is really simple. I'm also going to show simple goodie here. So for this, we're going to use change route diameter. So what we need to take care of at this assembly. I think something is in the background. Okay, just to load it. So when using this part, the change route diameter, if we're, for example, changing these pipes, for example, we need to take care of this flange sizes at the start and at the end. So what we can do here basically is we can just change the sizes we need. Okay, I'm just gonna miss. Never mind. Just gonna close up and gonna run it again. Just a moment. Apologies for this. I'm not using dedicated CAD workstation. For this, I'm using my home PC. Okay, and we're back and running. So we're just going to here, going to do change route diameter. So for this part, it seems like, do I have maybe an issue with the file? it seems that there is an issue with the file for some reason. I'm using, maybe because I've run it so many times over and over again. Well, be it, let's say, type drawing, let's say, maybe go on the slope. No. We'll change it on, we'll show it on a different example then, because it's simple. So I'm just going to go on a slope. Apologies again for this. Okay. Okay, we're just going to, I'm going to just change the order. So for the slope, it's very easy to set it. So when we edit the route in piping, to add a slope, we have the command add slope. So I'm going to put the slope segments, which segments need to use the slope, gravity plane, choose in which direction, down, and the start point. So I want it right here from the flange, and I can use either, I can use degrees or I can use units, whichever part you prefer. My suggestion is use this at the end when you completed your route, how your route looks like and performs. And if you need to change it, you can change it this way again. For removing the slope, since the slope creates two center lines to actually create the actual slope, we're just going to do right click and remove slope. It's a lot easier that way. So if we're adding the slope, it's the same thing again. So I'm just going to add it. And the slope is done under the angle I actually required. And for changing the route diameter, I'm just going to go back to the example I shown, and we can change it, for example, piping. The example we were doing, what we need to change here, we have a good example here actually. So we have one size here, then we have the change of the size here, which is propagated to the rest of the routing assembly. And important is here, if I go right click, edit route, and I go change route segment properties, I'm just changing this segment, and then I need to do this part of the segment, and then again this part of the segment, and I still need to take care of all these fittings. So here what I'm going to do is actually say change route diameter, and when I say like this section is first, and this will be the driving section, and I'm going to change slip-on flange. I'm just going to change this size, for example, to 4, and it's going to change, if you can see, my second fitting, which is actually the reducing T. And let's say I want that T to be either 3 inches or 2 inches. I can change it to, it will propagate this part. Also, the second fitting, that will change the diameters in the for the just a moment. So we don't need to, we can change the diameter of the pipe. You can see the original diameter, current diameter, and required diameter. So that's why this is good. So we're going to the next. I saw the question in the Q&A, just to finish this section. So here, the slip-on weld flange, I can also change the flange we're using. I can take the like 150 NPS for this part. Again, I control, let's say, maybe I want to change the schedule. I can change the schedule, and to the next one, it takes care of the schedule. I'm going to take care of this one and of the the upper one. Also, here you have the option automatically set elbows and pipes. So this can also be changed, but for the ease of use, sometimes this is more than enough. And when I say, okay, all the sizes now are just propagated to the size I required, and all the fittings are also changed. Okay, so I got the question in QA regarding why do we need slopes? Can't we use angles? Well, we can use angles, but it's a lot easier to actually. So if we have straight lines, it's actually a lot easier to draw them for some parts. And let's say I have this part of the assembly. So we have a 45-degree angle here. But let's say we want all of this, so all this section under different angles. So let's say we want to towards this our screen, so it goes to certain degrees down the whole thing. So this is where the slopes come in place. So if we are going to do something like this, so like for the elbows, yes, the angles are more than fine, but the slopes are meant for if we, for example, need to, this part needs to go up and it needs to be changed like for one, let's say 1 to 2 degrees, then we use a slope. I hope that clarifies the question. So back to our presentation. So we went to this part. So we're going to the routing spools and drawings. So where do routing spools and drawings come together? So if we create, let's say, we have a pipe from multiple sections and we want to clarify each section specifically. It's easier for the drawing manipulation because you don't have the whole big mess. And then it's a lot easier to create the drawings. And when creating the drawings, you can select your template sheet format, also the bill of material templates to use. We can also include auto balloons, and we can say, show me the route sketch, which is also a really nice feature. So we're going to demonstration number 7, and we're almost done. So regarding this, just a moment to clear up. Going back to SolidWorks. So spools, how we can easily clarify this part. So here, let's say we want to use, on the same example, we want to use spools. So if we go with the drawing with this exact pipe, so this is a lot of segments. This can be a mess when we want to clarify our information, how it's shown. So what we're going to do here, we're going to define spools. And let's say in the spool, I want this part of the section, and it will automatically grab also this auto T. I can remove it, and I can use it for the next section. So this will be easy part. The spool names, so how are they controlled for the auto naming? In the options, system options, routing, we have spools. So this is the format we can use. So we use hashtags for the number of digits, and we can say like assembly spool hashtags or configuration spools. So any of the, we can also change the joining component properties, the colors of this. So it's, this part is up to us. So I'm going to continue defining spools. So we got in this route subassembly we're doing, this is going to be the second one. This can stay as it is. For the third one, I'm just going to pin this so I can run it again. So this will be the second route, third spool, fourth, and we're going to use the fifth one. And the covering is separated. So this is one thing, covering is in the whole assembly. So what did spools also do? It also how we change the spools. So we can use define spools. If I want to edit one, I can just like click it. I can edit, right click on the folder, edit spool, and I can like say I don't want this part of my spool. I can edit it, and it also says, defines where is everything. So spool in this subassembly is here. Also, the most important thing when we're creating the drawing, so we're going to that bit. So I'm just going to save this externally, but for this route, now that I'm done with the design, I'm just going to say save in external file. Save only I'm going to save only this subassembly. It's going to be, I'm going to leave the name I used before and use the pipe drawing. For the drawing, I can use like any spool I need. Let's say I'm going to use for the main sheet, I'm just going to use the main display. Regular drawing, sheet format template, I can use whichever I need. So I'm going to include the default piping bill of material template. I'm just going to use a prepared one for piping or exploding. I will say include auto sketch bonus and show route sketch. And this will create my routing, scale it. Now I can edit it. Also, you have multiple uh, route properties. So if I need the route properties, for example, covering thickness, I can get the covering thickness for this. Also the IDs of the materials, I can get the pipe length, so I can get the lengths regarding the units I use. So there are route properties, and I can also combine for bill of material, everything else. So everything else is just the same as you would do in SolidWorks. For example, when I create the new, want to use the new view, I can just use, let's say, this display state. And I can say, I want to use this part of the assembly, this part, or even this part. And good thing is, if I want to do a center line, I can just select view. It actually, this is the part of the sketch, so I would need to show the sketch. I can just hide the segments so it can use the sketch. But when we're creating the drawings, I can just save here, save default location, and it's just a regular SolidWorks drawing now. And let's say I want to use a pipe drawing, and I'm going to use the spool, the different one. So I'm going to put this one. So now I have the whole thing, but now I can just like check, select the other parts of the sketch, and I can just use hides to remove them. But the dimensions, what I get, it's this dimensions is actually used tilde to the connection of the routing point. So that's the bit about routing drawings. So you can have different, so I can call it, let's say, spool 1, just for the sake of it. And this is just now regular SolidWorks drawing that you've created, but you get automatically the display states for the routing. Let's move on. Now, this bit is a little bit longer, but I'm just going to hop on and make it clear as possible. So if we want to create our own components, how we do it, we either reuse some components and edit them, or question, can we change the piping color? Yeah, we can change the piping pipes, sir. Just a moment. Okay, before I move on, why are the pipes appearing as solids, not hollow? That's only because it appears that way when we're editing the route. This is lighter on the graphics, but the pipe itself, as you can see, it's hollow. It actually consists of the outer and inner diameter, which I'm going to talk about at this part of the demo. And can we change the piping color? Yeah, we can change it. I can maybe even add it after. Actually, the colors are mostly defined in the part itself, which will be shown as well at the next bit. So this is why, because I'm using the default library. So we're going to use routing components, reuse some. We're gonna copy the pipes and tubes and just create specific configurations. Define the material. We can change the color, which will be used for the pipes. Use the design table. We can do the same for the elbows. We can do the same for the valves, and we're gonna test drive it. So the just before the last one. So what we're going to do, I can save this and exit. Okay. What we're going to do, I'm going to open up a pipe, which is the default one in the library. So, and let's say for this pipe, see, this is extrusion, just to take a notice of the sketch. So this is why the piping is rigid and it cannot be flexible. So it has a pipe sketch, which is already defined, and it can be easier for us to manipulate that when creating new pipe. And we have a filter sketch. Filter sketch is actually quite important for placing the pipe itself. And for this example, what I'm going to do, I'm going to do, say, in the same folder, and I'm going to name it PVC pipe. So regarding that material, I'm going to edit material. I'm going to set material, which is going to use PVC rigid, apply, close, and it will be white color. White color is okay because it's going to be different than the pink one we used before. And now, regarding the configurations, routing heavily depends on the design table. So for this part, I'm just going to use edit table. Maybe it would be actually better if I use the edit table in a new window. It's more, I'll like it to use it a lot more that way. So now we have a big list of the configurations we want to use. So in here, what I'm going to do, I'm going to remove some of those. And which ones I'm going to remove for the pipe. For the pipe, we're going to remove, let's say, all the schedule 80. So I can remove like pipe, let's say 0.5 inch schedule 40. It's going to stay. Everything is going away. So for this, we're also saying this. Delete. So for this part, we're just going to keep few sizes, not all of them. So this part of almost deleted the one I needed. So I'm going to keep half an inch, 3/4 of an inch, 1 1/4, 1 inch, 1 1/4 inch, 1.5 inch, and 2 inches. 2 inches after that, so I can add 175 near, and everything else can go away. And with this, it's done. So this also has some properties. These properties can be changed, but now just for demo, I won't be changing them. So I'm just going to delete a lot of these configurations. So, and here I have all my sizes I need. So for all the sizes, and if it's different, I can use configure. I'm just going to do configure material. So it should use the same material for everything. PVC, it's not here. I can browse for more, but yeah, PVC. So I can edit specification. I can have multiple things in the same file, but it's just going to use the exact configuration of the pipe regarding the connecting flanges. And just going to double check here. Okay, I'm just going to quickly do configure material. This. I'm going to say, yeah, browse for more. So PVC rigids, but okay, just so it could be shown. So the color can also be changed depending on the configuration, all of the pipes or even tubes. So it's up to your preference how you're going to use, or you're just going to use material specific. So this part is done. So for the next ones, I'm going to use the basic ones. And if I refresh the library regarding the piping and use pipes, here I have my PVC pipe. So for the next, I'm going to add now we're going to use the routing library manager to actually add some components. Just a moment. I see many people and also something. Okay. Okay. Can we add flexible tubing to the normal pipes for pressure gauges? I see. So flexible tubing, it will be actually the use of tubings. Actually, I'm not going to lie, I haven't tried using as a sweep and using it as a pipe. Didn't use that one. Didn't try it. So specs for sport, identify specification for each component. Ali, if you can clarify a bit on that. Where to find routing library manager? So either so the add-in needs to be on. So add-in SolidWorks routing, and it's either SolidWorks the assembly needs to be on for here to be shown if I want to access the routing library manager. So tools, routing tools, routing library manager, or we can go through the options, routing file locations, and launch the routing library manager. And if you're using the desktop version, routing library manager is a standalone application. So this is regarding this part. So if I want to add a new component here, let's say we want this coupling to be added. So first, this component does not need to be copied in the routing routing database. Why? Because there is a specific way we're gonna add it. So for this part, we have this simple coupling. So we're going to show it. So it's this part. So this is added. So we have connection. So the origin here is going to be used for the routing point, and the connection points are going to be used on the planes. And we're going to change the sides information with this. So for this, I'm going to routing library manager, routing component wizard, and where this one is going to start, it is to start routing component wizard. I'm using the latest version, so that's why. Routing component wizard, and here I'm just going to say which type of route I'm using. I'm going to do piping. I'm going to do so it's going to be either reducer or support. So I can also check any part I need. So whatever I need, I can check, use it. So whatever regarding for this can be used. Also, there is one thing I haven't created now, but it can be created later, which is actually the axes that are used for the placement. So for that, we're going to just follow up the information regarding the. So we're going to use other fittings, and we're going to use coupling union, and we just follow the steps here. So here, we don't have any any specific C point. So we're going to add C points. Route type. So here we're going to say fabricated pipe. I'm going to use this face, sits in cylindrical. It will utilize the center axis of this shape. So this is stub length, schedule field name, specification, so schedule value. I can also select the pipe. So for this union, fitting, I want to specify which pipe I'm using. So I'm going to specify the pipe I will be using for this specific. So this is one point, and it creates the C.1. And now we have the, okay, C.1 created. We need another. So we're going to create the same thing, but on the back side, just going to, again, PVC pipe is going to be used this part, and we need routing point. For the routing point, I can actually here use the origin. So that part is going to be utilized here. We can add more. It's optional. So for here, we need axis. Why is this important? When we are setting up the fittings, it needs to have an axis. So here, I'm going to either we can use existing or new. I'm going to create a new axis, and it's going to be created. So it needs to be vertical. So I'm just going to create them from the plane, top and right plane. Create, and this will be, what is good thing here, this will be automatically renamed later to the vertical axis. Part modeling is complete next. So if we want to open up, this component does not have design tables, so for different sizes. Maybe you have specific needs, you don't need different sizes to utilize all the configurations, but if you need, you will need to use it. So we can use like either create the, we can use either create from the file. I have the configuration table here set, so I'm going to create from the file and just use it so we don't spend a lot of time just manually editing the Excel file. So when it loads, we got our configurations. So it's set. So we can also set the another one. So we can have required design table parameter specification C.1. Also another ones we can also set it later. I'm just going to continue for this one. And for the configuration, also you can set specific custom properties exactly at this point if you need, and you can do paste. Okay, so the question is, I mentioned we cannot do isometric drawings because of the PID, but regarding the output, we can have ASCII, so we can use some specifications for the outputs. So it has so for when you're creating the export for it, it will carry that information to the other software you're gonna use for the either PID or the isometric drawings. Next, and now this is the important part. At the end of the creating any, so this is not specific to this component, it related to all components. So I can say this will be called PVC coupling. And I want this saved to the library and also save it to the database. And it will say here routing piping. Okay, it goes to the piping library. Do I wish to save? Yeah, it will be added to the library and it's done. So this part is done. I can also do the same thing, just going to quickly go through it. So I have an elbow that I want to use. So I need to open up the elbow. So this is a new component, piping elbow. So we're going to do. So I'm just going to reuse because it has all the sketches here already. So C points. So where I'm going to press one, this will be the one. Again, the pipe I'm going to use. This remembers the last component we've set. This will be this one. We're going to add new seed point here. Select pipe just to make sure that this is correct pipe. And for the, this is different for the elbows. Routing point goes actually on the, either I can use like the sketch axis, or I can use the specific thing. Let's say I can use this point for the, for specifically for the elbow. Just a moment, need some more liquid. We're basically done. Where I'm going to put it for this, so I'm just going to show this sketch and I'm going to use it here at the C.1. This is what I'm putting for the elbows. The routing point, just gonna hide it again. Now that we have it, this requires some different information. So this is all present. So if you're missing something, it will notify you. I strongly encourage for you to use the already existing components and recreate your new ones, or just use the copy. So where the modeling is complete, we're just I'm just going to copy paste the information for the elbow. So I'm just going to create it from here. Create design table, from file, browse, worksheets, elbow, open up, edit. It can happen. Don't worry about this. So if it says, I'm just going to again start it. I will not use link to file, but okay. So I would need to add manually design tables, so that part stays the same. So, but let's say we're done and I want to test it. So I'm just going to use the default one. And again, I'm just going to use the PVC. So it's utilizing the, say I'm going to save the database. So instead of creating manually the whole design table, I can add it later and edit it in the database. I'm just going to save it. It's going to be added to my routing location. So instead of doing, so we're a bit overboard time, so we can finish it in next 3 minutes. I'm just going to use the what we created so far. So what I'm going to start with, I can just use the any flange here. So what I'm going to do here, so for this specific lesson, if I'm doing the creating the flanges, creating components, case study. So I'm going to use to have the flange here. I have it. I'm just going to use the drag and drop the flange, but to have the added in. We didn't add it to the library, but I'm just going to use the 3-point weld flange. So I'm going to use the 1.5 inch. So this I can use the not use this one. Okay, I'm going to change the pipe I'm using. So I can change the elbow I'm using. So it's piping. I can change the location of this later. So because it doesn't have a configuration, I cannot use these elbows, but just for the sake of the how it's created, since we got at least the coupling. So when this is created, so when changing the size, also the color is changed. So you change the colors in the components. And regarding the piping, so regarding the union we created, if I need to go to the edit route and I go to like adds union, because it's not the same configuration. it won't be added. So you have to be careful that you have the correct information regarding creating the components. So this is this part. So I'm just apologize for hurrying up over because of time. So follow each step in the routing library manager when creating the new component. It needs to have the design tables, so they need to be created. And now for the last part, we're gonna use SolidWorks content. So how we can use, so regarding so I'm going to do this. I'm going to go to the routing library manager. I'm going to do the routing file locations. I'm going to set this to my millimeters. We're going to millimeters now. So this will be set. And now to use the content, there is one important rule. You have a lot of components here. So let's say we want Dean steel. So I'm just going to control, click it. I'm going to download the whole package. Now that I have it, that it's downloaded. So I'm just going to take a look. So, okay, we have a steel folder. So why am I looking at that? Because that will be for the last slide. So if I go to my routing library location, I can just go here, design library, routing, and I can go to piping and choose this location and extract it. So this is already set of the components. And if I want, I can redirect my library. So routing library manager, I can directly redirect it to the steel folder I have here. So there's also, I'm just going to refresh it, piping, and we have steel. So here, the same structure, flanges, for example, if I want to use any of this case study, let's say we want this DIN assembly, I want flange, neck, or welding type, just to check my note. So what we're going to do, a flange, we're gonna use DIN 2628 to 2628, and we're just going to drag and drop it, and we're going to, so for the route size, we're going to say 250. Or actually, sorry, that's a big one, too big one. So let's say with the 50, that will be okay just for now, it doesn't matter. But again, be careful about the piping sizes which use. So if I go to the routing, so I go to steel pipe, I'm just going to use this pipe. It takes the configuration, so it's already loaded. So this is in millimeters. So we can also set use standard length. So let's say every 1 meter, we want to use the coupling, still union. So for which union we're going to use? For the union, we're going to use flat seat U1, and we're going to say open. Elbow, again, we can use the elbow. We need to set it, so instead we could maybe have use the apologies, use the specification template regarding this type. So this is going to be type 5. It has the correct configuration and created. So I'm going to use default one. So I'm going to check, say this one is, instead of connecting, so let's say 5,000. So I'm going to put this at the end, exit, and you can see that it inserts coupling at the every standard length. So you have a lot of options to explore, ready to use already models inside your SolidWorks. And that brings us to the end of this long presentation. Just a notification regarding the library. So we have routing library separated, so piping, tubing, electrical, and so on. Set it by with standards, and then you can set it by materials. So and inside then use the use the information about how the parts are stored. So you have it nice and tidy. Any questions? And apologize for taking this a bit long. I hope you liked it for this one. So there are some questions. So this one I haven't answered. So can you also run flow simulations on the routing and show example? Sadly, I'm not doing any simulations, so that's a bit outside my territory to properly explain it. But routing can be used for the flow simulation or any simulation. Why? You have the already have the models, etc. If you can choose the meshing type you need. Regarding the flow, for flow, you just need to close the starts and the ends, so it doesn't have like any holes, so you have the closed volumes. But yes, flow simulation can be used with routing. So that means if you want to use, let's say, HVAC for routing and then use the HVAC simulation for flow, you can do it. Any additional plugin extension that could provide piping and routing uh, features. There are a lot more options here. So I've touched the basics. So while I was creating this presentation, I had in mind that if someone starts, what would the main things be to start? And then the question, I could go over a lot more in depth, and actually I should go a lot more in depth regarding creating the routing components, because it has a lot of information it takes. But the main cue is what I wanted to show, that you don't copy the component and add C points manually and then just copy paste it. You want it to add it to the database, because the database is the heart of the routing. One quick thing here, routing and piping and tubing database. For here, you have import data, export data. Very simply put, if I delete anything from this folder, so I'm saying if I delete anything here, so if I select import that data and say synchronize, it will go through the whole my routing database, and it will remove here from the list any component that's not here. And for the export data, we can export this. For example, if you use 3D Experience, so 3D Experience can manage the routing database. Here you would use the sync the database, for example, to the 3D Experience platform. So this routing library manager is the heart of it, and creating the route component, it has so much more options, and there are like tag scheme, schemas regarding the fields, so how everything behaves. Then when creating components for the isogen data export, there's just so much to it. But I plan to keep to the basics, so you can start creating your routes. So yeah, I have free time, and if you do have free time, please shoot out the questions. So yeah, I apologize, I'm not able to show any information regarding the creating the flow simulation. Maybe I could do it regarding the ask talk to my colleague to actually prepare the presentation regarding the flow simulation for this, because it can be utilized. But there's one question I haven't answered, and that's from Mr. Ali Saad. I hope I pronounced the name correctly. And it was about, does SolidWorks support identify specification for each component? If you could elaborate a little bit more on that. Uh, books regarding the standards, actually, I can look it up for you, and if it's all right, since sorry, I'm new to Bevi, and can we put the additional training, additional materials to regarding this session as a discussion?
Yes, yes, it is fine.
Uh,
Yeah.
So yeah, I can look up to that and provide information so it can be added as a part of this session.
Yeah, I'll be waiting for them and I'll upload them once with the recording.
Okay. Any other
Okay.
questions? I guess this is it for now, what it seems. Well, thank you so much for having me. It's been a pleasure. And Tuyo, the stage is yours.
Okay, they know for sure. I'm so grateful for the presentation that has been from the basics up to the almost the standards up to the design library. It has been so great to host you, and it has been a powerful session because piping and some section of SolidWorks are not perfectly utilized, and I believe with this session it will be a powerful one. So with that.